So today I'm going to try and explain to you what the Arrhenius definition is, as well as the Bronsteel Lowry definition for what acids are, bases are, and what alkalis are. So the Arrhenius definition basically tells us what happens in an aqueous solution to acids or bases. And an aqueous solution is just the acid or the base in water. So we can just look at the behavior with acids, which give H plus ions in an aqueous solution. What that means is, as you can see, because the equation here, when we have HCl, which is an acid, in an aqueous solution, so within H2O, it separates or dissociates into H plus and Cl. One thing to note is that H plus can also be called a proton. This is because H by itself, without losing an electron, is already just one proton and one electron. So that plus means that it's given away that electron, meaning that this is just one proton, which means H plus is interchangeable with proton, meaning when someone refers to protons, they're just referring to H plus. So to summarize, HCl, which is an acid, and just the example here, will dissociate into H plus and Cl. And because it dissociates into H plus and something else, we know that HCl is in fact an acid. Similarly, the rule for alkalis in the Arrhenius definition is that it separates or dissociates to give us OH minus ions. For example, we can look at NaOH. NaOH has two parts, Na and OH, and it dissociates to give us Na plus and OH minus. And again, the fact that it dissociates into OH minus tells us that this is in fact an alkali. So understand, the alkali is for the Arrhenius definition, meanwhile the base is for the Bronsteel Lowry definition. Again, we can see right here that it's an alkali because it dissociates into OH minus and something else. Something important to note is that an alkali is just a soluble base. What that means is an alkali is a base that's able to dissolve in water. In the Bronsteel Lowry definition, we can see that an acid is defined as a proton donor. Proton meaning H plus, as we discussed before. So I'm a base on an alkali, but a base is a proton acceptor, meaning they take in H plus. So representation in an equation is H2SO4 plus HNO3 is equal to HSO4 minus plus H2NO3 plus. In this scenario, our base is HNO3 and our acid is H2SO4. As you can see in this equation, when we move from this to this, we can see that a proton has been donated, as now it's missing one. Likewise, when we look at the movement from HNO3 to H2NO3 plus, we can see that there's been an addition of a proton, meaning a proton accepted. Because of this, we can infer that since this is doing the donating, this is in fact the acid, and since this is doing the accepting, this is in fact the base, meaning that our base is HNO3 and our acid is H2SO4, hence the Bronsteel Lowry definitions.